In this video, I will show you how to graph ellipses and circles. You can tell this is an ellipse because of the way it is. It's got these fractions happening, and it's equal to 1, and these are different, so ellipse. Anyway, the bigger one we call a squared, the bigger denominator. So if a squared is equal to 4, then a is 2. And this tells us, because the a squared is in the y term, I'm going to go plus or minus 2 in the y direction. So I'm going to go up 2 and down 2, and these will be my vertices. So my vertices are 0, -2 and 0, 2. Alright, the smaller denominator is b squared. And if b squared is 1, that means that b is also equal to 1. Because b squared is in the x term, that tells me that when I move the b value plus or minus 1, I'm going to do it in the x direction. So I'm going to go left 1 and right 1. And these will be my covertices. So 1, 0 and -1, 0. The center is clearly 0, 0. We can tell from the equation when we see x squared and y squared, that is going to be 0, 0. Now the major axis is vertical. As you can see, it is stretched in the vertical direction. We can also tell from the equation when the bigger number, the bigger denominator is with the y term, it's going to be stretched vertically. So I'll just put a V here. Now that we know A and B, it's time to find C. C squared is equal to a squared minus b squared for an ellipse. So that means that c squared will equal 4 minus 1. So c squared is equal to 3, which means that c is equal to the square root of 3. For graphing purposes, it would be useful to know the decimal approximation. Okay, so the c value is radical 3, which is approximately 1.7. That helps me with the graphing. The c value tells you where the foci will go. They always go the long way. They always go on the major axis. So I'm going to go up 1.7 from the center. That'll put me about here. And I will go down 1.7. Alright, so these are my foci. Now, when I label the foci, I'm not going to say anything about 1.7. I'm going to say 0, radical 3. Alright, that's the upper focus. And of course, 0, negative radical 3 is this lower focus. Okay, now we can also go ahead and say what E is. The eccentricity is always the c value divided by the a value. So that's going to be radical 3 over 2. Okay, and we can certainly go ahead and graph the ellipse now. And there you go. That was so fun. Let's do another one. The bigger denominator is going to be a squared. So that means a squared is 16. That means a is 4. Now notice that a squared is in the x term. That means I will do plus or minus 4 in the x direction. So I'm going to go left 4 and right 4. And these will be my vertices. So this is going to be Oh yeah, once again we know the center is 0, 0. That's very important because it's simply x squared and y squared. So the vertices will be -4, 0 and 4, 0. Alright, so because of the denominator of 4, that'll be the b squared, alright? The smaller denominator is always b squared. So that means that b must be 2. Because b squared was with the y term, I will do the plus or minus 2 in the y direction. So I will go up 2 and down 2 like this. We have a and b, so it's a good time to find c. C squared is equal to a squared minus b squared. So that means c squared is equal to 16 minus 4. So c squared is equal to 12. So c is equal to the square root of 12. We know that 12 is 4 times 3. So c is 2 radical 3. For graphing purposes, a decimal approximation would be useful. So c is approximately 3.4. This helps us graph the foci, which will always go on the major axis, alright, which is the long way from vertex to vertex. So I will go, what did I say, 3.4? 3.4 to the right, alright, which would be right about here, and I will go 3.4 to the left, which is right about here. So those are my foci. Okay, and I forgot to label my covertices, which are 0, -2 and 0, 2. And now I can label the foci, which are, keeping in mind that c is 2 radical 3, this will be -2 radical 3, 0, and this one will be +2 radical 3, 0. Okay, the e value, eccentricity, is the c value over the a value. So the eccentricity would be 2 radical 3 over 4, but 2 over 4 reduces down to 1/2. So this reduces to radical 3 over 2. The major axis is horizontal, so I'm going to put an H there. As you can see, it is longer in the x direction, so that's horizontal. And I think that's everything. So let's go ahead and graph the ellipse. So there you go. Alright, finally we get one that does not have center 0, 0. The center will be the opposite of these two numbers. So because I see -3 and -2, I know the center will be +3, +2. Alright, so this will be the center of my ellipse. The bigger denominator is going to be a squared. So a squared is equal to 9, which tells me that a is equal to 3. Because a squared is in the denominator of the y term, I'm going to do plus or minus 3 in the y direction. So I'm going to go up 3 and down 3 from the center that we just identified. So if I go up 3, I'm here. If I go down 3, I am here. These are the vertices. So this lower vertex is the point 3, -1. and the upper vertex is 3, 5. All right. The vertices are always showing us where the major axis is, from vertex to vertex. So the major axis is vertical. The b value, well, b squared is going to be the smaller denominator. That means b is 2. Because the b squared is in the x term, I'm going to do my plus or minus 2 in the x direction. So I'm going to go 2 to the right and 2 to the left from the center. So that gives us the covertices, which are 5, 0, and the one on the left is, did I say 0? That's wrong. Let me start over. All right, this covertex on the left is 1, 2. And the covertex on the right is 5, 2. Okay, that gives us enough information to find the c value. We know that c squared is equal to a squared minus b squared. So c squared is going to equal 9 minus 4. So c squared is equal to 5. So c is equal to the square root of 5. Let's go ahead and write that down. So c is radical 5. For graphing purposes, it would be useful to use the decimal approximation, which is 2.2. Okay, so the c value tells us where the foci are. The foci will always be on the major axis, along with the vertices. So I am going to go 2.2, or radical 5, up and down from the center. All right, so if I went 2.2 up from the center, that would be about here. If I went 2.2 down from the center, that would be about here. Now, how do I label these, though? Because I surely can't say anything about 2.2. So instead, I'm going to use the radical form, which is radical 5. Let's see. All 5 of these points are all lined up at an x value of 3. So the x-coordinate of this focus is clear. It's going to be 3, something. The x-coordinate is definitely 3. Same thing with this one. All right, it's going to be 3, something. The only thing we have to be careful about is the y value. Take note of the y value of the center. The center has a y value of 2, and we are going up radical 5. That means the y value of this focus will be 2 plus radical 5, and we just have to leave it like that. The y value of this lower focus will be 2 minus radical 5. I'm going down by the c value of radical 5. So I can simply put 2 minus radical 5. So again, 3, 2 minus radical 5, that's the lower focus, and 3, 2 plus radical 5 is the upper focus. Let's go ahead and say the eccentricity, which is always c over a. In this case, that's radical 5 over 3. All right, that's it for the data. We can go ahead and graph this thing. And there you go. Let's take a look at number 4. The larger denominator is going to be a squared. So a squared is 25. That means that a is 5. Because the a squared is in the x term, I'm going to do my plus or minus 5 in the x direction. Whoa! Slow down. Getting ahead of myself. I really need to say what the center is before I can do anything else. So looking at the x squared, that tells me that the center will have an x coordinate of 0. And looking at this y minus 1, I do the opposite, and I think positive 1. So 0, comma 1. Let's write that down. The center is 0, comma 1. So this is the center right here. So what was I saying about a squared? Oh yeah, a squared is 25, so a is 5. Because a squared is in the x term, I'm going to do my plus or minus 5 in the x direction. So I'm going to go 5 to the right, and that will be a vertex, and I will go 5 to the left, and that will be a vertex. That's why my vertices are negative 5, comma 1, and positive 5, comma 1. Now let's talk covertices. The smaller denominator we will call b squared. If b squared is 9, that means that b is 3. Because b squared is in the y term, I will do my plus or minus 3 in the y direction. So I will go up 3 and down 3 from the center. So I will have a covertex here and a covertex here. The coordinates are 0, comma, negative 2 and 0, comma, 4. All right. Clearly, as soon as we said the vertices, we can know that the major axis is horizontal, because this is the major axis connecting the vertices. It is horizontal, so I'm going to go ahead and put an H right there. Time to find the c value. We know that c squared is equal to a squared minus b squared for ellipses. So c squared will equal 25 minus 9. So c squared is equal to 16. So c is equal to 4. Well, isn't that nice? It comes out to be a whole number. That tells us where the foci are. The foci will always be on the major axis along with the vertices. So this 4 tells us that I will find my foci to the right 4 and to the left 4 from the center. So there will be a focus here at 4, comma 1, and there will be a focus here at negative 4, comma 1. Alright, that is disappointingly simple. Alright, I want some square roots or something. Okay, we might as well find the e value while we're taking care of all these letters. The e value is always the c value over the a value. So that's going to be 4 over 5. The eccentricity. This number reflects how circular the ellipse is. The closer to 0 this number is, the more circular the ellipse is. I think that's it for all the data that we're supposed to fill out. So let's just go ahead and draw the ellipse. Boom! There you go. These last two graphs are circles. You can tell because we have no denominator. We just have x plus 1 squared plus y plus 1 squared equal to a number. This is the format for a circle. When you have a circle equation like this, the center is going to be the opposite of this, comma, the opposite of this, similar to an ellipse actually. So this would be negative 1, comma, negative 1. Now this number represents the radius squared. So if the radius squared is 4, that means the radius itself is 2. That's enough for us to graph a circle. So if the center is -1, -1, that means the center is right here. If the radius is 2, that means if we go up 2, down 2, left 2, and right 2, we will be graphing points on the circle. Okay, so let's go ahead and just draw the circle. And that's really all there is to it. After graphing all these ellipses, circles seem kind of anticlimactic. This is another circle. Again, the center will be the opposite of this, comma, the opposite of that. So +5, comma, -2 is the center. This is the radius squared. That means the radius must be 3. So let's see, 5, comma, -2 is the center. There you go. Radius of 3. So we will go out 3 in all directions. And that shows us where the circle is. Kabam! Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.